Good afternoon, and welcome to this Oasys Gofer webinar. My name is Norbert Kovac, and I'm a Senior Business Development Manager at Oasys. As we're letting everyone into the webinar, I just wanted to double check if you can hear me. So if you, for example, you could put something in the chat, say where you're joining us from, that would be a great starter. Okay, let's see. I did see it. One hands up. Okay. Leeds, London, Newcastle, Oslo. Welcome. India. In India, it's after work, isn't it now? Thank you for joining. Okay, brilliant. So it seems like you can hear me and you're all here. Great. So I hope you have your teas, coffees, anything ready, some snacks, because you're in for a treat. Looking at the attendees, I can see some familiar names. I wanted to say faces, but clearly just the names, and some new ones as well. So for any of you who are new to Oasys, I just wanted to let you know what Oasys stands for. So Oasys is over Arab Systems, and we are Arab's in-house software developer. We develop structural, pedestrian simulation, and geotechnical software. I'm excited to see you all here today for our geotechnical webinar on Gofer, because we do have quite a few new developments, which I'm sure you're going to find quite interesting. Just a few general notes. We will have a question and answer session at the end. And if you can just put your questions into the Q&A section. So if you look at the top of your screen, you will see towards the middle a Q&A button. So if you can just put anything in there, that's brilliant. Don't worry if you put it into the chat, we will just copy it over. But if you just put it in there, that's easier for us to review at the end. If you already have some questions, go for it. Nothing intended. Okay, so today's presenters, we have Mark Skinner. He's our geotechnical portfolio product manager. Raul Perulero Serrano, he's our product manager, and Alvaro Rodriguez Martin, one of our developers. And with that, I'm going to hand you over to them.
Brilliant. Thanks, Norbert. I hope everyone can hear me okay. Thank you all for coming. As Norbert said, without further ado, we'll get on with the webinar. Just click on to the next slide. There we go. So what are we going to cover today? It's all about Gofer. I thought we'd start with a bit of a recap on Gofer, what it is, just a bit of background, just in case there are people on the call attending the webinar that haven't seen Gofer before. Well, then the main part of the webinar will then move on to show you what's new. We've got a lot of new stuff to show, which is hopefully interesting to you. After we've gone through that, we'll then start to look at in a bit of types of things that we can model, and then we will look at some of the things that we might add to Gofer in the future. What's coming next? So I hope that'll be a good interesting webinar. Let's see where we go. All right. So what is Gofer? I've tried to do this as few words as possible, just a lot of pictures. Gofer is our new cloud geotechnical finite element analysis tool. It's the first new geotechnical software that we as Oasys have done in I think about 20 years, and it therefore marks a bit of a step change in the way we do things. The most obvious sort of thing there is that it's in the cloud. It's a website, which is quite a change from how we've done things in the past. So we'll get into details of why that's good later on, but it's good to bear that in mind. It's a cloud geotechnical software. It's a general finite element analysis tool, so you can model soils and structures and how they interact. That's the idea. And pretty much you can model what you can draw, what you can do with the tools provided. So hopefully that's a good overall description. What we've got on these tiles here is just showing you a range of the sort of inputs and outputs, I guess, some of the support that's available as well, and we'll get through those shortly. On the next slide, I've tried to sum up a Gofer in one sentence, which is not easy to do, but there it is. So Gofer combines the benefits of cloud software with geotechnical FEA capability to unlock exciting potential. We'll get onto that exciting potential later, but it's really trying to emphasize the fact that the capability of doing geotechnical FEA combined with cloud capability is really quite interesting. And hopefully the new features we show you today will sort of step that up a bit and get that potential unlocked. So we talk about Gofer as reimagining finite element analysis. So I thought I'd try and dwell a bit on what's different about Gofer to other software you might have used, and I've tried to sum that up on this slide in one slide, I suppose. So on the left there, we talk about ease of use. We've really put a lot of effort into trying to make Gofer as easy to use as possible and as easy to learn to use as possible, because we know that to have confidence in a piece of software, you need to get familiar with it, and that is an investment, if you like. It takes a lot of effort to become familiar, get confident that it's giving you the right results, get confident that it's suitable for the situation you're trying to model. So that's where we've put a lot of effort. It's hard to give specific examples of that. It's the overall interface, the ease of drawing things. But two specific examples I have thought of are, for example, that Gofer takes care of things like mesh refinement and the boundary fixities, sorts those out for you, so you don't have to worry about them. So hopefully it saves you time in getting your model drawn, getting your model analysed, getting those results out over what you might be used to. That's what we're hoping anyway. So in the middle there, the next sort of key benefit is around leveraging cloud. So I mentioned earlier, it's essentially a website. The analysis is done away in a data center somewhere. It's not done on your machine. So you don't need a powerful machine to use Gofer. Just use on your laptop. And you don't in fact have to install anything. All you do is go to the website, log in, and there it is. It's ready to go. Another big benefit of it being in the cloud is that it's continually updated. So you never have an out-of-date version of Gofer because the website is updated. We've had new features in, and they're just there for you. A similar sort of vein, it's in a browser, so you can open different tabs and you can run different models at the same time. And whilst stages are running, you can see the results of previous stages whilst the latter stage is still running. These are all benefits of it being in that browser situation. Lastly on that, then, you can also share your Gofer models really easily. It's a URL, so you just copy the URL, send it off in an email, something like that, and your colleagues can grab the model. So ease of use, cloud power, and then on the right there we're describing it as next generation finite element analysis. So having that bundled together really opens up some interesting possibilities. So Gofer has a user API, and we'll show you a bit more about that later. But by connecting your logic through the API, so you can write your own code with Gofer as the analysis in the middle, you can use that to really explore options, explore sensitivity analysis, optimize things. So essentially, we've written there, Gofer can power your workflows, and we think that's very interesting and quite exciting. So I hope that was okay. It was just supposed to be a very brief recap of kind of the intent behind Gofer, what we've done with it. We launched Gofer as a brand new product in October, so it's about 6 months old, just over. And this webinar really marks quite a major upgrade, I suppose. So what we're going to do now, if I can click the next slide, is get on to what the team have been working on over the last 6 months or so. Got quite a few things to show you. We've arranged them into 4 kind of categories. Firstly, some improvements around getting to know Gofer, and that goes back to the confidence and getting familiar with the software. Then we'll show you some things that improve its modeling capability, so features really. Thirdly, we've got a group of things that sort of just make it easier to use really. Show you those, and then there's a few extra bonus items at the end that again hopefully improve the overall experience. Okay, so getting to know Gofer. As I said just now, this is about building confidence in Gofer, and we really want you to be confident in Gofer. It's very, very important to us that we're as transparent as possible with how it works, showing you examples and that sort of thing, so that you can just look at those and feel like it's the tool for you. So we've got a couple of new tabs in Gofer, and I'm going to hand over to Raoul, who is going to show you these whilst I control the screen. So bit of a double act. Let's see how we go. Just bear with me. Are you there, Raoul?
Thanks, Mark. Yeah, I'm here. Thanks, thanks everyone for coming today. Yeah.
There we go.
Brilliant. So as you can see here is we've got the examples models tab, and here it's a range of tiles, and behind those tiles there's a selection of models that we've been working on, and it's mainly based on either case studies, synthetic examples, or also like from well-established solutions from literature. For example, the steady-state seepage solution of an earth dam. So the way these ones work is you can read through them as a technical, like you would do like a technical note or like a technical paper. It's structured in a way that it gives you the context. It's also giving you the parameters and giving you all the ingredients you need to build those models by yourself from scratch. And also we've included some images on that are so easy to extract once you're going through those stages. And we've done some comparison with other tools for benchmarking and just give you that peace of mind on the validation of those results, and also on getting those those results from the models. Also, you can copy those models and you can bring them across to your collection, and as simple as a click, and you get to see that you can either get across the material properties, and you can see the models, you can see the stages, and then consult the results, and then you can also get into the edit mode once it's copied in your collection. So that's the idea. So you get that confidence in using and a lot of emphasis on showing you how easy it is to use. Then on the other hand, we've got the Learn tab. It's a bit of like self-learning beyond the documentation, which is very well assorted, and you can start always there. I'm a big fan of documentation. I like always reading those instructions first and getting familiar, and then getting into a bit more advanced things. But those videos, that selection of videos that you can see there, you can also consult them in the Oasys YouTube channel. So these ones are targeting particular functionality, particular tools, and that you can use. And once you go in there, you'll get through that selection, and then just give you that confidence on using them, always from the site or from the YouTube site. And these ones, as well as the example models, it's an ever-growing collection. This is going to grow with Gofer. So we are collecting and expanding those selections. And yeah, I think back to you, Mark, now.
Brilliant. Thanks, Rob. Hope that was okay. Sorry, I managed to hit refresh the page there whilst the portal was opening. So went back around the loop. That's okay. Brilliant. Let's go back to the presentation. There we go. Hope that's showing up again. So examples and learn, 2 new tabs, and we hope they provide some nice examples and little videos to help you sort of get familiar with Gofer. That's the idea. Okay. Right, next section. So modeling capability, arguably what some people are most interested in. So what we've done here, we've got 3 new features to show you in this section that really, we hope, step up what you can draw in Gofer, essentially. I'm going to go back into Gofer to show you these, but what I'm going to show you is props, node links, and interfaces, which are all new things that we have added or are about to add to Gofer. So flick the page around, but let's jump back into Gofer. Let's go for this one. Got some tabs ready. Right, so just an example. I've got a model open here in Gofer, and I'm going to start with props. So what I've got here is just some soil blocks. So if I zoom out, it's really just 3 layers of soil. I've drawn a couple of structures. That's the item that sticks in red, and the idea is that this will be excavated. What I've done is drawn a prop here. So this is a prop. You can position these on a structure anywhere. It's just a node object, and what it is basically like a sky hook. It's an imaginary prop of a defined length. You can just set a spacing into the page. You can see the properties open on the right there. So you specify the EA, the angle of the prop, so you can change the angle. You specify a length, you specify a spacing. It then acts as a spring that's fixed at the other end, the imaginary end. So as that wall moves, it will pick up load. And if you specified a stiff prop, it will stop the wall moving. It will act as a spring. And it's really, if you've used our other product through, it's similar to the props in through. So it's sort of modeling convenience for modeling those props or propping slabs, things like that might go against a wall or whatever other situation you think it's relevant for. So I'm going to show you node links kind of at the same time, and then I'll show you some of the results of those. This is a node link over here. So it's a similar sort of thing in that it's a spring, but what node links are modeling is essentially a connection between 2 structures. So you see I've got a potentially a retaining wall here, and I've buried a deadman in the soil over here, and a node link can connect them. So it's a sprung element, but this time it's got slightly different properties. So we still specify EA, got a spacing into the page, but we also have a compression and tension limit. So the node link will compress or expand up to that limit, and it will transmit forces from one structure to the other without directly influencing the soil or being influenced by the soil. So it's almost like the elements is behind the soil elements. This would be quite convenient for modeling something like a ground anchor or a tie rod, as we have here between a deadman and a wall, those sorts of situations. Cool. So I've got a run version of this model ready. And this is what you see when they run. So here I've excavated the soil, and as you'd expect, these walls want to move inwards, and you can see in the message panel on the right that the prop and node link are picking up force. Node link's picking up less force because the deadman is also moving, as you would expect. If I deform the mesh, you can see that they are influencing the wall somewhat. Got quite a high scale factor on there, but it's you can see that they are causing the shape of the wall to change. I think I've used quite stiff wall elements there, so that it's not moving very much, but shows the effect. What I failed to do is actually draw them, so let's just have a go at that. So you access them in the structures menu. Props are really easy. You just click, and then it generates a new one. Enter the properties there. And node links, again, they're in the structures menu. Add node link, and Gofer will only let you draw them between 2 structures. You can see the red X there showing that I can't just drop that in the middle of the soil. There we go. Properties come up on the right. And what we've done is tried to make it quite smart in terms of when you can have these on and off. So this is configure stages. This is where you arrange your construction sequence. So you're turning objects on and off. If you switch off, say, this wall, then it will automatically switch off the node link because it's not appropriate to have it on if it's not connected to anything. Cool. I think that's about it on props and node links. Let's move on to interfaces. So go back to draw model. Interfaces, as I said, they'll be activated within the next few weeks. The way we've done this is inside a material. In the strength parameter, this is only for more Coulomb materials, you can specify that a soil has an interface ratio. So that ratio is between 0 and 1. Wherever that soil then contacts a structure, it will apply that interface ratio, ratio automatically. So if you want to control the level of friction between your structure and your soil, so it factors the angular friction and the cohesion, then applying that interface will do that. And the idea is it's automatic. You don't have to draw the interfaces or anything. They're always there if you turn them on for that soil. If you go from stage to stage and decide you want to switch on or off the interface, then just use a duplicate of that soil with the interface on or off, and Gofer will handle the rest of it. So that's how we're implementing them. It's there's no drawing, I think, so I can't show you drawing them, but they are a property of the materials, and should be active soon, next week or so. And what we're planning to do in the example models is we'll have an example up and running showing what they do as well. That's the idea. Okay, brilliant. Let's jump back into the presentation. I think that's those covered. And there we go. Okay, so we're going to move on to another section now, which will be making things easier. And I am going to hand over to Alvaro, who actually built these things, these improvements. He's going to explain what they do. Thanks, Alvaro, if you're there.
Thanks, Mer. Welcome for coming. So we have presently the possibility to import materials into your current models, as you see on the GIF, from any other model that you are the owner of. Once you click the button at the top right, you will get the option to search the material that you want to select, and then simply add it to your material. You will then be able to modify that new material or add it to the soil block. Next slide, Mark. We have also added envelopes to Gofer structure and cross-section graphs. As you can see in the GIF, once you click the envelope button, it will show a range of results for all the stages except for stage 1. Envelopes will also be shown if you download the SVG. Finally, we have also improved the way vectors are shown in the result page. Firstly, we have set the vectors to scale independently within each stage, rather than being proportional across the stages. The largest arrow being displayed will always be the same size. We have also simplified the scale bar so that you can now choose to adjust the arrow size between 10% or 200%. And lastly, we have added a dynamic legend, which will grow or become smaller, depending on the scale that you have set. Thanks. Back to you, Mark.
Thanks, Alvaro. That's brilliant. I'm particularly pleased with the material copying. I know it was a pain previously to have to re-enter your materials every time you created a new model, so it's nice to be able to copy them in from your previous ones. Should save a bit of time. Fantastic. So next category, right? So as well as I've called this. These are just a few things that sort of generally make Gofer better, I suppose. We've started there with moments. Again, just like the props, all you do is drop these on a structure, but it's really the fact that you can now model a moment load on a structure. We didn't have that previously, so that's all in and working. I'll show you these. Let's show you them all. The next two are line load visualization and cross-section measuring. But I think it's probably best if we just jump into Gofer and show you them. So line loads, you go into the loads menu and you can draw a line load as before. The difference is now, once we enter some values in, 0, 0, done. Right, so now we've added, firstly, labels to show you which end of the load is which was a potential oversight before. It was a bit difficult to know which end was 1 and which end was 2, so that's now clearly marked. And also we've added these vector arrows, which are designed to give you an indication of the load, the resultant load at each end, and the relative magnitude as well. It will show up. So it's a bit easier to see what you've actually applied. So the values of line loads obviously can change along the length of the line loads. We just give you the value at each end, just to provide that information. while I'm here, I'll draw a moment. So they're again in the loads list. So we can just simply add a moment, click where we want it, and specify the value. And they are anti-clockwise positive. I always get that wrong. There we go. That's how we add a moment. Lastly then, so cross sections are a relatively new thing in Gofer. You draw them just like the way you draw any other line in Gofer, but the difference we have is that they are drawable after the analysis has run. So when you create your cross section, it's actually saved in the model. So when you rerun your analyses, you don't have to redraw the cross section, which is quite a good thing. Now, I call this cross section measuring, and that's because this feature is shortly to be debuted. It's not actually live, and I'm showing you the live version of Gofer. So what I'm going to do is just show you the test version because it will work in the test version. Yep, so there we go. So can you see the two numbers on there? This will be switched on in the next few days. It just gives you a better idea of the length of the section that you're drawing. So if you want to get a precise number, it's a bit easier to do it. You can do several if you want a crazy cross section, no problem. There we go. So jumping back to that one, when you have results in your model, this one, yeah, the cross section will show up. And you can call that up again. Brilliant. Okay, let's go back in. So keep flicking between the presentation. Here we are. Right, what's next? What's new? Okay, so very important, this one. The documentation for Gofer. We've obviously improved this to show the new features. In fact, I'll show you this in Gofer as well. But we've also done some other improvements in the documentation. This is how you find it. You go to the question mark in the top right, into the help menu. You get a pop-up showing you some of the sort of key controls and key functions of Gofer. Hit full documentation, and it will open up. So yeah, as well as showing you all the new features, we've also made some improvements to try and make it more, well, easier to read essentially. So improving the graphics, improving how things are labeled, and the search as well. I hope is improved a bit. So that's where that is. Whilst I'm in the docs, I'm just going to draw your attention again to the section on the API, which explains how to find all the information you need to use Gofer's user API. So what we have in here, first is a link to Swagger, which I'll show you on the next slide. That lists all our endpoints. So they're the commands you can use to interface with Gofer. We also have in here a number of examples, and depending on whether you're an Arup user or not, just click the appropriate link. And what you'll get is essentially a big code sample, which you can drop into a Jupyter notebook and see how to interact with Gofer models. They're all saved as JSON, so it's quite straightforward to manipulate them, especially the examples we give are Python based, and that probably, well, it lends itself really to manipulating those files, which will help you get into using Gofer for automation. So there we are. Let's jump back in, and the next slide, we're just showing you really the Swagger here. So it's a website, and lists all those endpoints, and you can click them and expand them and see the structure of the data that Gofer will send back to you when you use those endpoints. Hopefully it's nice and clear. Brilliant. Okay, so that's all of our new things to show you, new functionality. Hope that was useful. What we thought we'd do now is move on to sort of Gofer's capability and what you can model. So what we tried to do here is show again on one slide the sort of key overview of Gofer, the key functionality. I won't go through all of them. Some of them are obvious to you, but we are using linear elastic Moore-Coulomb ground models. We can model drained and undrained. We do have C-Phi analysis working, and we have steady state seepage. You haven't seen much of that today, but it's there in the background. So you can draw your flow boundaries, point or line flow boundaries, and set up your own groundwater regimes, should you wish to use those as an input. The structures, as you've seen, is they're expanding across. So we've got the pins and springs. They've been in there for some while. For the structural connections, we've got node links and props that have just been added. And then we've got our new interfaces to arrive shortly, and the ability to share models quite easily as well. So I hope that's a good roundup of where we're at. I haven't mentioned the API on this slide. It's kind of a separate thing, but that's okay. So quite a lot of people have asked, well, what can I model with Gofer? And that's quite a difficult question to answer, because it's one of those. Well, the method lends itself to drawing anything really, whatever you can draw with the geometry. Now, obviously, we're not going to say you can model anything. That would be inappropriate. But in terms of a few ideas of the things you could reasonably model, try to draw some of them here. So we're thinking sheet piles and piled walls, diaphragm walls, that sort of thing. Essentially, excavations that are retained. We think you could do aspects of piles, ground improvements, try to draw those there. And then gravity retaining walls should be feasible. That's what I tried to draw on the right. And then retaining walls using ground anchors and props should be perfectly feasible as well. Now, what we're not showing on this slide as well is anything to do with steady state seepage. That's those sorts of problems. We do have a few examples of those in the example models. So seepage through a dam, etc. That's within the capabilities now. And I guess very, very generally, the sort of loading and unloading of soil within the realms of the ground models that we have is feasible. So really, anything you can draw, as long as you understand what you can draw and the limitations of the methods being used, but that would be, any software you use, that would be the case. I'm sure we'll think of some more examples. We can put them in the chat as we go forward. Okay, so what's coming next? We wanted to give a bit of a brief overview of what we're thinking of in terms of what will be added next into Gofer. I won't do these in the order presented, but the team are currently working on adding consolidation. So I hope that will be added to Gofer sometime over the summer. That's obviously a key piece of functionality that we would like to get in. We are looking at circles. I'll show you an example of that on the next slide, but really that's the first step for drawing tunnels. So not just drawing the circle, but the structure around it as well. And we are looking at branching stages. At the moment, it's the way you get around that, or the way you would do that is simply copy the model. It's very easy to clone a model. It's one button click. Because it's a website, it's a database. Your model is duplicated in a matter of seconds. But we're looking at whether we can get some kind of branching of stages into Gofer itself. Soil models, that I guess that goes without saying. We currently have we currently have more Coulomb and linear elastic soil models, which we consider are appropriate for the everyday analysis that Gofer is aimed at, but we would obviously like to consider which models to add next. So we're looking at that soon. And then lastly, it's a bit ambiguous, this one, options. Now, the idea is, again, because this is in the cloud, it's quite easy to run several models at the same time with different options. So think, for example, of varying a parameter, varying I don't know, a load, a stiffness of a structure, and seeing how that affects your model. We're looking at building in some functionality next that will easily allow you to do that without writing your own code, just in the front end. So hopefully that will be useful and popular. So that just gives you an idea of where we're heading next. We can continue to improve Gofer, and that is easy because it's a website. We can just add these features in over time. So there we are. Right, here is just to show you some work in progress on circles. So this is our colleague Julia drawing a circle to define the radius, and then you can drag it around. That's the idea. It's obviously a lot more complicated than polygons because we have to cut the soil blocks using the arcs. But yeah, we hope that will be available some point over the summer as well. We'll start with circles and then see how we go. We do have, I haven't mentioned this still, but we do have DXF import, so you can import other shapes and as sort of guideline geometry and then draw around them, which would help get your geometry into Gofer, we hope. Cool. Right, so I guess that's almost at the end of what we wanted to present today. Just as a bit of a summary, I guess this page is a bit of a roundup on Gofer. So 5 key points there. We hope Gofer is easy to use and is easy to learn to use. It's something we put a lot of effort into. What we're aiming Gofer at is this sort of everyday analysis. We like that phrase. It's designed to make the everyday easier. We hope it will get you the answers you need easily, more easily than you may be used to. However, behind the scenes, we've got quite a powerful analytical capability here because it's in the cloud, because you can scale up the number of analyses you're running, and then that goes into the next gear, into overdrive, when you add the API and let your code do that yourself. And lastly, then, Gofer will keep improving and evolving, as I hope you've just seen. There's some more exciting features coming soon, so we can unlock that exciting potential. Right, just to finish, we'll just remind you, this is Gofer's website, oasysgofer.com. On there you can find information about Gofer, and if you wish, you can sign up for a trial, which is what this animation is showing you. Just a case of popping in a few details, click the button, and we will create you an account, and you will be straight in. Easy as that. And I believe one of my colleagues will put the link to that in the chat imminently. So that's us for today. We hope that was useful, and of course, if there are any questions, be delighted to chat about them. Back to you, Norbert.
Brilliant. Thank you, Mark, Raul, and Alvaro for that. Mark, you actually kind of answered one of the first questions we had.
Oh, did I?
Yes. The first question was, can I try out Gofer or request a demo? So yes to both of them. As Mark was showing it, you can just go on our website and you can set up your trial account over there, or you can just simply email us on oasys@arup.com and we can sort that out for you. And similarly for demonstrations, we're more than happy to set up online demonstrations to you and your colleagues. Okay, so let's have a look at the other questions. Another question was about, is Gofer available under the Unipack suite of software? So currently, no, but we are looking into this. If you can just email us again at oasys@arup.com, it is something that we can discuss, and we are keen to discuss, as Carol mentioned, because we are looking into working with several universities. Okay, let's see another one. Okay, so this is a technical question. I always struggle with the concept of interfaces. What are they and how do they work? Carol, would you like to elaborate on that?
Yes, sure. So the interface is really a sort of artificial mathematical element that's inserted between the structure and the soil. So down that boundary where the soil block meets the structure, everywhere there's the edge of a soil element, if you like, when the mesh is discretized, we add another very thin, virtually zero thickness element to allow those two things to move slightly relative to each other, and the amount they can move or slip depends on that interface ratio that Mark described. So it works well mathematically. It's used in a lot of FE programs, the same sort of idea, and that's what we're introducing here. But the main difference is that you don't have to specify the interface. The program does it all for you in line with that. trying to make things easier theme. There's another
Brilliant.
question actually
Yes.
come into the Q&A about whether interfaces can be introduced between, say, two structural elements which border each other. And that is, we've allowed for that in future, but we're starting with the soil property type first. But the intention is to then have a property available to add to a structure as well. That'll be, you know, more of a medium-term feature, I think.
Yes, and is that addressing the second part of the question? Can you control consolidation by means of time and or residual excess?
Yeah, that's kind of a separate question. Yes, that's again on the features under development list, but that is under active development at the moment. So obviously you can imagine that's quite a lot of solver work as well as the graphical user interface work to add those extra parameters, but it's being worked on at the moment. Yeah.
Brilliant. Another question, an easy one. How many models can I run simultaneously? Is there a limit?
Oh, so at the moment, yes, there is. It's 3. So you could have 3 models running, as in analyzing. If you start to send more for analysis, they'll just queue up. And you can, there's no physical real limit on the number of tabs you can have open. It's probably down to your machine's memory, your machine spec. We will increase that limit in the future. We will, we'll take it away up from 3. And we're particularly interested in, if you're using it from code, that limit might need to be a bit higher. But yeah, yes is the answer.
Great, thank you, Mark. Another question, will you be sharing the recording video of this meeting? I would like to share it with my colleagues. Yes, I believe Neve has already mentioned that we will be sharing this. It will be on the same page where you registered for the webinar, but we will also probably going to send out a follow-up email with the link to the recording. Okay, another question. Can I share models with colleagues that have no Gofer license? Is there an available view-only mode functionality?
So not at the moment. Yeah, that's something we will have to consider how that works. At the moment, you need an account to view the models. In theory, it would work if you had a trial. But there are a number of features that are not available on the trial version. So to get the full experience, you need an account. Yep.
Brilliant. Also, Carol, I think I'm coming back to you because there's a long question with 2 parts, and there's a middle one which we didn't actually address. You mentioned there is a seepage module. If I need to say consolidate to a new groundwater or pore water pressure equilibrium condition, how would I do that? Run a seepage state to establish the new steady state, but followed by consolidation stage?
Yes, that would be pretty much. So the seepage stage would establish the pore pressures that would act as the start value for the consolidation, and then in the consolidation stage you would set the new flow boundary conditions and allow the consolidation stage to run until they were reached, or for whatever time you set on that stage.
Brilliant. Also, can you control consolidation by means of time and or residual excess pore water pressure? I believe we have already addressed this question.
Yes, and those 2 sort of termination conditions are exactly what we're building in. So either a time step or a residual excess pore water pressure.
Great. Another question is, recently I had an issue finding the results of a slope stability model in the trial version, where I did not get any results even after an hour. It could be an inappropriate material property or with the geometry. My question is, could I know what's wrong?
Okay, probably in that sort of case, it would be best you can download your model file, or you can send us a link to your model, and then just in the same way that we showed in the demo, we could clone your model and have a look at it. Obviously, we've got all the code behind, so we can run through and see what's causing that analysis to stall, whether it's a data problem or something. And then we would get back to you. So if you submit a support query on that, we would look at the model.
Brilliant. Another question, what soil models do Gofer have? Example, more column or hardening soil?
Yeah, so at the moment it's more Coulomb is the main one we would expect people to use, but you can do linear elastic. But it's high on the list of things to look at. Which soil models to add next. So, yeah,
brilliant.
Feedback showed us that was convenient for quite a chunk of people's day-to-day work. So that's why we started with those. Yeah.
Thank you. Do Gofer packages support Norwegian and Canadian codes? How about seismic analysis?
Oh, that's two good questions there. So at the moment there are no codes in there, no partial factors. You could obviously put them in yourself by adjusting parameters. Again, that is something we're looking at adding. I've forgotten the second part. Oh, seismic. Seismic. Yes. Again, not yet, but it's on our list of things to consider. And obviously, some parts of the world that's quite important.
Indeed. Next question, can interfaces be introduced between elastic elements if they are not drawn and are a soil property, say between two discrete concrete elements, for example?
Oh yeah, that was the one that I mentioned before. So we've built that into the background code, but we haven't exposed anything in the user interface to allow you to set an interface property on a structure. But it's quite possible the way we're building the code in the background to do that. So it's something that we could introduce in the future.
Brilliant. And so far this seems to be the last question. Is there a way to find how much time a model takes to complete the analysis? Are the analysis results saved, or do we need to analyze every time?
They're saved. Yep. So when you run the model, it will be run the next time you come back into it. We don't show you a number of seconds that it's taken because it's actually very hard to measure that the factors that affect the running of the analysis. Some of it is on your machine, some of it is on your internet connection, some is on where the solution has taken place. Although we do actually monitor it to see if there's any problems. Yeah, I don't know if hopefully that answers the question.
One thing we've looked at is trying to assess model complexity. So
yeah.
Numbers of elements, numbers of nodes, types of material used, that sort of thing, because obviously it's early days for Gofer. So we want to build up our knowledge of how to measure, what's useful to measure, and how we can scale up the cloud resources and the infrastructure to support the things that people want to run. So the more you analyze with it, the more we'll find out and be able to scale up for the demand.
Exactly. And on that note, now everyone can go and sign up for a trial. Okay, brilliant. So that was the last question. Does anyone have any other questions? You can still pop them in here and we can address them. We still have a few minutes. I believe, yeah. Okay. Okay, it seems like everyone is happy with those. In that case, thank you very much for everyone for coming. I have to single out, especially for those of you who are joining in from the other side of the world where it's really late already. Actually, Carol, you're in Hong Kong, so thank you very much for joining in as well.
I've got jet lag, so I'm fine.
Brilliant. Okay, and yes, as we mentioned, the webinar will be is recorded, and it's going to be published on our website, as well as we are going to reach out to you about it. If you have any questions, you can still send these to us at oasys@arup.com. And yes, we are going to have lots of more news coming out for Gofer. As you can see, it's one of our fastest developing software, so keep an eye on this space. For the time being, thank you again for coming, and see you soon.